Hi, we are Masterworks Engineering. Masterworks Engineering was hired to design the east stands and scoreboard structures for the new San Diego State Aztec Stadium. My name is Eric Casada and I served as project manager on the Aztec Stadium project. Aztec Stadium will be a 35,000-seat stadium that will serve as the home for Aztec football and as a world-class entertainment hub for the San Diego community. The scope of our work included conducting a thorough geotechnical analysis of the area to identify potential hazards and develop a sound foundation system. We also developed a comprehensive structural design for the lower and upper seating areas and the scoreboard. We also addressed important construction parameters of the project, including costs and scheduling. Through our team of engineers, we were able to design what is an efficient, cost-effective structure that will serve as the backbone for the project that is to be Aztec Stadium.
Hello, my name is Mark Wambua, and I am one of the geotechnical engineers currently working on this project. The main task assigned to me was to come up with a foundation design for the stands located on the east side of the stadium. To accomplish this goal, I would first need to assess the boring logs given to us by Group Delta. I could then identify the different types of soils located at the site. Using this information, I would determine where the weak soils were located and if there was a possibility for liquefaction in any region. It was also important to calculate bearing capacity for shallow foundations and end bearing capacity for deep foundations to see which foundation type would work out best. I came to the conclusion that a deep foundation design for the east stands would ultimately work best.
Hi, I'm Alan Abutin, and I helped out with the geotechnical and structural portions of this project. From the boring logs provided to us by our consultant Group Delta, we were able to classify the soil as soil site class D, which is a stiff soil. The soil is low strength considering the loads that will be applied to it. Based on our findings, it is recommended that the soil that is currently there is replaced with higher strength types that will properly support the loads that will be created. Our cut-fill plan is based on the fact that there are steep elevation gains and losses in the soil.
Hi, my name is Darren Tith, and I'm the structural/construction engineer for Masterworks Engineering on the Aztec Stadium Structure Project. My responsibilities for this project include land development and assisting on the structural design of the stadium. Because of the steep elevation differences, altering the landscape to have a neutral elevation at the site location to build the stadium on is necessary. To do that, we need to calculate the amount of cubic yardage needed to cut or fill the site to get the flat location. To calculate the cubic yardage needed, we separated the land on site into different sections with subsections inside of them. After careful calculation, we found the amount of fill needed in cubic yardage to be 432,113 cubic yards.
Hello everyone, my name is Ahmed Syed. I'm a structural engineer and CAD lead for the Aztec Stadium project at Masterworks Engineering. My responsibilities included designing the upper and lower east side stands for the stadium. The main goals of this project include sizing members to overcome maximum deflection, moment, shear, and axial forces, acting on frame members and precast risers, while also adhering to code like ASCE 710 and SCEI 716. The reinforced concrete system is made up of columns and raker beams. After careful calculation, we recommend a raker beam with a 3x6 cross-sectional dimension with 20 number 10 steel reinforcements of 60 KSI strength and 4 KSI strength of concrete. The columns supporting the rakers and risers would consist of 2x2 cross-sectional dimension and 8 number 10 steel reinforcements of 60 KSI and 4 KSI concrete.
Hi, my name is Ray Robles, and I was in charge of the construction portion of the SDSU Stadium East Stands project. A couple of the tasks that I was responsible for were the access and project site layout, the sequencing and phasing of work, the drilling and lift plans, the cost estimates, and lastly, the project schedule. Some of the challenges that I came across during the construction phase were making sure that each task was accounted for in the schedule and flowed into the next task with appropriate flow. Another challenge was pricing for some of the items, such as the precast risers for the stadium seating, but with the help of Ruth Lehman at PCI West and Eric Mullen at Mullen Concrete Products, we were able to come up with a solid number for our estimate on the east stands.